Algebra 1, we're going to do section 3.1. These are the notes. So you can write notes at the top, and the section is 3.1 functions. I need to focus this. There we go. Functions. Okay, put your name at the top, put the date, put your period, all right? Your own name, date, period. And so we're starting a new chapter, and so we're going to be talking about functions. Functions are like, for instance, they're like a relationship between one thing and another. So like your grades are a function of how much time you study. The amount of money you owe is a function of how much you've bought. So there's two things that are related. One thing is based off the other. So we're going to start with the definition of a function and some problems that you will be asked on your homework. So what is a function more in mathematical terms? Each input has exactly one output. Now, usually in a lot of the problems we do, the input is like the x variable, and the output is like the y variable. Like the y depends on the x. They can be different letters. So let's look at a couple examples and try and decide if they are inputs or not, if they are functions or not. So every input has exactly one output. Only one, cannot have more than one. So example 1, part A, we're going to look at some ordered pairs. -2, 2, -1, 2, and 0, 2. Now, one of the things that I guess I would take from this, also another way to interpret this, is that x cannot repeat. I'll show you what I mean. X cannot repeat. Cannot repeat. Y can. Y is okay. That's another way to think about it. So here, you could say -2 is the input, x is the input, and the output is 2. -1 input for x gives an output of y. So this is x, this is y, this is the input. That's what you plug in. This is the output. When you plug in 0, you get 2 out. Now, there's no repeated x's, which is good. Repeated y's, that's okay. That's all right. Okay, but since x didn't repeat, this isn't something that you would usually write, but we're just writing it right now in our notes. Since x didn't repeat, it is a function. Okay, so the answer is function. That's what you're going to box. Let's look at some other ways that the information could be given to you. It could be given to you in a table. So example part B, input x, output y. And so let's see, our inputs will be -1, 0, 0. And the outputs are going to be 4, 5, and 6. So the table could be horizontal, sideways like this one, or it could be vertical up and down. Here's the problem. When you plug in, so you plug -1 in, you get 4 out. You plug 0, you get 5 out. You plug 0, you get 6 out. So if I plug 0 in, I get different answers at different times. That's bad. Because my one input has more than one output, and the x's get repeated. So the x's are repeated. And this is the kind of work you could show in your homework is just circle that. Write the problem down and circle it. Circle the problem if there's a problem. So this is not a function. Okay. You don't have to write x repeated, but you could just circle it and show it to me. Okay, C, this is called a mapping. It's a different way of giving you the information. So input, output. So the inputs are listed underneath input. It's not really a table. Okay, so we're going to do those. And a lot of times they kind of circle these. And then they draw arrows. Like -1 gives 4. -3 gives 15. Negative 11 gives 15. So you might be, oh, these two x's go the same thing. No, that's okay. There's no repeated x's. In fact, we could write these as ordered pairs, and it might make it a little more clear what's going on. So we could write these as ordered pairs. We could say, oh, this is negative 1, 4. This is 3, 15. And then 11, 15. Okay? There are no repeated x's. That's good. There is a repeated y. That's okay. Okay, we can have repeated y. So this is a function that passes it. Okay? So pause the video if you need to at any point to copy down what I'm writing down to give credit. Let's talk about another way of deciding if something is a function or not, but without the numbers, just based off more of a picture. So this is called a vertical line test. Okay, vertical line test. And so what a vertical line test is, it says a graph represents a function when no vertical line passes through more than one point. Okay. Graph represents a function, so it is a function if no vertical line passes through more than one point. Vertical line is straight up and down. So let's look at a couple examples. So write these down. So A, these are always going to be graphs. So let's go ahead and just draw a graph. Okay, we'll put some little marks on here for the values. Label the axes, x and y. Label our axes, values. So I'm going to put, let's see, we're going to put a few dots on here. We're going to put a dot here, like 1, 2. Another dot here, another dot here, and another dot up here. So that's going to be the problem we're given. Now, another way you could think of this is call this like the pencil test or pen or whatever. And so you can use your pencil to kind of help you. So if you're holding this straight up and down, if it gets to a point where it's going to cross more than one at a time, that's bad. Up right there, look, those two end up crossing the pen at the same time, like right above and below each other. Or you could draw a vertical line, and these you have more than one. If you draw a vertical line here, it's okay. If you draw a vertical line here, it's okay. But it just takes one place for it to go bad. Okay. In fact, you could even write the values next to these points. Yeah. So we're gonna say not function, not a function. Okay, because of the vertical line test. Okay, let's do another one. Now that's called a discrete graph when there's little individual dots. But we're gonna see graphs that are like all connected and have lines and stuff. So this one's not going to be little dots. It's going to be something more like this. And we should put arrows on the ends to show that the graph keeps going. And so if you're taking a vertical line, pen or pencil, boom, crossing it more than once. Like anywhere in here, it's crossing it two times at a time. Like here, it crosses just once. Okay, that's all right. Here, it doesn't cross at all. That's fine. But over here, it's crossing it twice anytime you draw a vertical line. So that's not a function. Okay, let's do one more, part C. We've had a couple not functions, so maybe we should do one that is a function. 1, 2, 3, 4. 1, 2, 3, 4. Label the axes. So this graph's just going to look like this. So it kind of like ends right here and keeps going forever. So if you do a vertical line test, if you draw a vertical line anywhere, it crosses once. Never crosses it more than once. So this is a function. Every input, every x has one y. All right. Let's talk about domain and range. Domain and range. So what is the domain and range of a function? So the domain is all possible input values. A list of them, a list of all the possible and all the ones that can be used. And usually that's X for domain. For our problems, we might use some other letters sometimes, but it's the thing you plug in, the first thing, the input. So all the input values, and the range is all possible output values, or usually Y, okay? All the output values. So let's do a couple examples here. Example 3, part A. I'm going to start with a graph. I mean, we could do these from those tables and stuff like that too. You do them from graphs. So I'm going to put some points on here. And let's see if we can kind of put them in the same spot. So I'm putting one right here. And I'm going to put one right here. And I'm going to put one right here. And I'm going to put one right here. Okay, so you can copy that down. So what's the domain and what's the range? Well, the domain is all the x's and the range is all the y's. What might help on these graph ones is to go through and like label these points. So this is 3, 3, right? X is 3, y is 3. This one is 2, 2. X is 2, y is 2. This one is -1, 0. X is -1, the y value is 0. This one is, looks like, -3, -3. To the left 3, x is -3, down 3, the y is -3. So with these, it might be a little easier. So the domain, a lot of times what we do, just to be a little lazy, we just write D, capital D. And then if we're listing a bunch of individual points, we put them in these like curly braces. And we list them usually smallest to biggest. So these are the x's, -3, -1, 2, and 3. And in the range, we just use capital R. And it's all the y values, -3, 0, 2, and 3 in order. And that's it. That's your answer. Okay, let's do another one. B. This is another graph, but this graph's going to look a little different. I'm going to put a couple of values on here. So this graph, it's going to start here, and then it's going to go up to here with a straight line. It's going to come over to here with a flat line, and then it's going to go up to here with a straight line. This is called a discrete graph with individual points, and then this is like a continuous graph where it's all connected. For the domain, we're trying to figure out, well, what are all the possible x values? Now, this time, it's a bunch of x values. And so you might look left to right and say, well, okay, what's the first left it goes? And what's the furthest right it goes? It goes from -2 to 3. So the domain, we're going to usually write these as inequalities. X is in between -2 and 3. And it has an or equals to, because these are solid dots. If they're open dots, we go and put the or equals to. -2 to 3. And should go smallest to biggest. The range is all the y values. So the y values, figure out, maybe extend the line over to the y-axis and say, oh, well, it's all the y values in between -2 and 2. Doesn't go above 2, doesn't go below -2. So the range is -2 to 2. And so usually when you do these, all the things open up towards the bigger things as you go left to right, smallest to biggest, And so that's how you would write the domain and range for a graph that has just like lots of points in between. If they're just separate little dots with the little curly braces, and you just list them. All right. Last thing, we do example application problem. So application problem. So the application is the function c equals 6t plus 8. So we don't always have to use x and y. Okay, 6t plus 8 represents the cost c for t-shirts plus shipping. Okay, so this is our kind of our word problem here. A, identify the independent variable slash dependent variable. Okay. Now, independent means to not have to depend on anything. So independent means it doesn't depend on anything. Dependent means it does depend on something. So the independent variable is the one that we plug in. It's the input or the x value, or in this case, the t is what gets plugged in, right? The dependent variable is what you get out, or the thing that depends on the other one. So C, the cost depends on how many shirts you buy, right? You don't really think of it the other way, that the amount of shirts depends on the cost. No, the cost, how much you're going to spend, depends on how many shirts you buy. So that the cost depends on the other one. So this is the output, or the Y, or in this case, the C, right? So we're going to write this down. Independent variable. This is going to be our answer. Independent variable is going to be t-shirts. And the dependent variable is going to be C, cost. That's it. So you got to figure out what independent means. It doesn't need anything else. The T doesn't need anything. The C needs the T, though, right? The Y usually needs the X. B, this is still connected to this problem. The domain is 1, 2, 3, and 4. What is the range? The domain is 1, 2, 3, and 4. They're giving you the domain. They want to know what the range is. So they're giving you the t values, the inputs, and they want to know what the outputs are, the cost that go with those t values. So an input-output table is a handy way of figuring this out and showing your work. So we're going to put t 1, 2, 3, 4. And then we're going to have cost equals 6t plus 8. And we're going to show our work. We're going to say, well, the cost is when we plug 1 in for t, 6 times 1 is 1 plus 6. Right? Order of operations gives you 14. That's the cost. So that's one of our range values. So we go through and we just do this for each of them. Plug 2 in, plug t equals 2 in for t. In parentheses, 6 times 12, 6 times 2 is 12, plus 8 is 20. Keep going. Plug 3 in. 6 times 3 is 18, plus 8 is 26. 6 times 4, 6 times 4 is 24, plus 8 is 32. So your range is, now these are discrete, just individual values, so we put them in the curly braces, 14, 20, 26, and 32. That's your answer. And the table is where you can show your work. Okay, so we're going to be doing monitoring progress for some classwork. And it's going to start on page 104. And we're going to do problems 1 through 12. They're at the bottom of the sheets. I would use the Student Dynamic ebook because there's little blue arrows that will show you exactly how to do each problem if you get stuck, and see if you can kind of figure this out really well so you can be ready for your assignment and be able to do your assignment successfully. That's it.